Dissolved oxygen is one of the most important indicators of water quality. Freshwater lakes, like this one, are complex ecosystems. They rely on a delicate balance of several biological factors, including dissolved oxygen, to maintain the equilibrium of balance for flora and fauna in the region. You might not know it, but aquatic organisms, like us, rely heavily on oxygen. The amount of air we breathe contains about 20.9% oxygen gas by volume. The oxygen in air that dissolves into water is about 35%. The oxygenation of lakes and ponds has enormous benefits. It reduces the amount of harmful algae that grows in our systems, as well as promoting a healthier pH and other water quality parameters. Now this in turn promotes the healthier growth of fish, native organisms, as well as healthy green phytoplankton. But perhaps most importantly, proper oxygenation reduces the amount of harmful sediment that settles on the bottom of water bodies, which is typically one of the most common signs of an aging or stagnant pond. All of this together promotes a naturally healthy environment that reduces the amount of algicide treatments and other costly maintenance required to upkeep our freshwater bodies. This is where we come in. Using perforated dispersal oxygenation technology, or POND, our team has been able to develop an open source, low cost means to be able to combat this problem. This is how it works. We have the DO sensor that uses the principle of electrolysis to measure the DO, and the temperature sensor to measure the temperature of the water. This then goes back to the brain box to calculate how much air is needed to pump back into the system. This information is then used to control the compressor. And utilizing a simple process called artificial destratification, oxygen is fed through tubes to the diffuser, which introduces oxygen back into the lake system. The bubbles that rise induce a vertical mixing within the water that help with this destratification. To ensure an efficient, yet eco-friendly project performance, the entire pond system runs entirely on solar energy. Let's dive deeper into each component and the design process along the way.
This is the dissolved oxygen sensor we chose to include in Project Pond. This model uses a galvanic probe to detect the levels of dissolved oxygen in the water. Its simple setup, maintenance, and cheap price made it the ideal choice for us.
This is a temperature sensor we've chosen for Project Pond due to its low cost and ease of use. The prototypes shown here illustrate the enclosure that we've designed to house the temperature sensor to ensure its durability throughout the seasons.
The Brain Box received a handful of different designs to optimize the durability, ergonomics, and to ensure it contains all the necessary technology to keep the system running. Controlling the system, we've chosen to use a simple Arduino microcontroller. The purpose of the Arduino is to monitor the temperature levels, dissolved oxygen levels, and voltage levels coming from the solar panel. The Arduino Uno R3 comes in at a lower cost compared to other microcontrollers, with a unit cost of only $23. The small dimensions make it very easy to install almost anywhere, and as you can see, it can even be incorporated into our 1:6 scale model. With this prototype, we're able to simulate temperature readings as well as voltage readings. These values will allow us to calculate the proper amount of dissolved oxygen to pump back into the body of water.
The air compressor we've chosen is an electric powered compressor that's small in form factor, leading it to be portable and easy to use in any location. It can pump out 3 to 4 cubic feet per minute, which will provide ample oxygen to the diffuser to dissolve into a water system. These prototypes show how the compressor will integrate into the overall pond system.
It's the FlexiDisc 9-inch disc air diffuser. It has 6,600 engineered release surfaces, which is up to 20% more than comparable models. It also has a 0 to 5 CFM airflow range, which is compatible with the air pressure of the air compressor. It has a specially designed EPDM membrane, which improves oxygen transfer efficiency.
There are 4 separate electrical loads: the temperature sensor, the dissolved oxygen sensor, the Arduino chip, and the air compressor. The main source of power is the solar panels. However, there is a backup battery system for when there is no sunlight. The battery is capable of powering the whole system for 20 hours, and the solar panels can recharge an empty battery within 9 hours.
And after the hours of work our team has put into Project Pond, this is what it would look like.
All in all, things tend to have a bit of a domino effect. The lack of oxygen can lead to more algae and cyanobacteria growth, which can be detrimental to wildlife populations, reduces water quality, and can be harmful to us in the process. Project Pond gives people easy access to a system that positively impacts organisms in our ecosystem, as well as the lives of people in our community. This is Project Pond.